All right, today we're going to dive into the world of data mining. We're going to talk about how we sift through this massive, messy river of digital information to find those priceless nuggets of gold. The hidden insights that pretty much shape our entire world.
So, have you ever had this happen? You're just talking about something, maybe a vacation spot or a new pair of shoes, and then bam, an ad for that exact thing pops up on your phone? It feels like magic, right? Or, let's be honest, maybe a little creepy. Well, the real answer isn't magic, it's data, a truly staggering amount of it.
Okay, to get a sense of the scale we're talking about here, just think about this. Way back in 2008, Google was already processing 20 petabytes of data every single day. I mean, that's 20 million gigabytes. And look, that was ages ago in internet time. That river of data, it's turned into a full-blown ocean since then.
And this absolute explosion of information, it has a name: big data. It's basically the digital ocean made up of all the footprints we leave behind. Every social media post, every credit card swipe, even data from scientific gadgets and mobile sensors that are tracking just about everything you can imagine.
So what actually makes data big? It's not just that there's a lot of it. It really comes down to these three things, what they call the 3 V's. First, you've got volume. That's the sheer, mind-boggling scale we've been talking about. Then, there's variety. We're not just talking about neat numbers in a spreadsheet. It's everything from text and pictures to videos and live sensor data. And finally, there's velocity, the absolutely insane speed at which all this info is being created. It needs to be processed, like, right now.
But here's the thing, and it's a huge catch. Just because you have a ton of data doesn't mean it's useful data. In fact, most of the raw information we collect from the real world, it's an absolute mess. In the industry, they have a name for it: dirty data.
So what does this dirty data actually look like? Well, it can be incomplete, like a form where someone forgot to fill in their occupation. It can be noisy, just full of errors, like a salary field that says -10. How does that even happen? Or it can be totally inconsistent, where someone's age is listed as 42, but their birthday makes them 26. And at the end of the day, it's simple. You can't make good decisions with bad information. It's the classic garbage in, garbage out problem.
So that's the central challenge, right? How in the world do we take all this chaos, this messy, massive flood of information, and somehow turn it into something clear, reliable, and actually valuable? Well, the whole process starts with a super critical and honestly often overlooked step called data pre-processing. You can basically think of it as the cleanup crew. They have to come in and get the entire site ready before any of the real building can start.
Now, this whole pre-processing stage has 4 major jobs. First up, you've got data cleaning. That's where we fix all those errors and inconsistencies we just talked about. Then there's data integration. This is where we pull together information from all sorts of different places, like, say, your purchase history from one database and your website clicks from another, and create one unified picture. Next up is data transformation, which is all about standardizing everything so you're comparing apples to apples. And finally, there's data reduction, where we intelligently simplify the whole dataset to really focus on what matters most.
And here's a stat that honestly blows most people's minds. This entire cleanup phase, everything we just described, can take up to 80% of the total time and effort of a data mining project. Seriously, 80%. Finding the gold is actually the fast part. It's getting the data ready that takes almost all the work. Okay, so once our data is all clean and organized, it needs a place to live. But here's the thing, not just any old database is going to cut it. For this kind of heavy-duty analytical work, you need a specialized home called a data warehouse. So, why the special treatment? Why this fancy warehouse? Well, think about a regular database, what the pros call an OLTP system. It's built for speed and day-to-day stuff, right? Like your bank processing an ATM withdrawal in a split second. But a data warehouse, or an OLAP system, is built for a totally different job, making big decisions. It holds huge amounts of historical data, all summarized and ready to go. And it's designed to answer really complex ad hoc questions, not just handle simple repetitive transactions.
All right, let's recap. Our data is clean. It's all stored away in our high-performance warehouse. Now, and only now, can we get to the really exciting part, the actual process of data mining. This is where we finally start digging for that hidden gold. So, what exactly is data mining? The formal definition is actually pretty great. It's the process of finding patterns in data that are 1. Valid, 2. New, 3. Useful, and 4, and this part is absolutely crucial, understandable. We're not just crunching numbers for the sake of it, we're looking for meaningful insights that a real person can actually understand and use.
Okay, to make this a little less abstract, let's check out one of the most common and powerful data mining techniques out there. It's called classification. And its whole goal is to predict a category, or a class, for new data based on what it's already learned from old data.
So how does it learn? It learns from something called a training set, just like this one. In this example, an algorithm would look at all this historical data on tax returns. Its job is to find the patterns that separate the people who cheated on their taxes from those who didn't. See that cheat column? That's the answer key. It's the pre-labeled class the machine is trying to learn how to predict.
And one of the coolest ways it learns is by building what's called a decision tree. It's kind of like the machine is playing a game of 20 questions. It starts by finding the best possible question to split all the data into groups. In this case, the first question it might ask is a really simple one. Did the person file for a refund? And just that one question already starts to separate everybody into different buckets. And it just keeps going from there. The tree keeps asking more questions, splitting the data into smaller and smaller groups. It'll ask something like, okay, for all the people who didn't get a refund, what's their marital status? And it continues this process over and over until it has isolated groups that are almost all cheat or all no cheat. What it's done is create a perfect roadmap for predicting what a new person is likely to do. Now, this whole ability to find patterns and make predictions, this isn't just some theoretical thing for tax returns. It's happening all around us, every single day, and it's shaping the world you and I live in.
I mean, just think about where you see this stuff constantly. Remember that ad that seemed to read your mind? That's target marketing. When a bank approves a loan application in seconds, that's credit scoring. In hospitals, doctors use it to help with medical diagnoses. That little alert from your bank about a suspicious charge, that's fraud detection protecting you. And of course, anytime a website says you might also like this, yep, that is pure 100% data mining at work.
Yeah, this quote about fraud detection really nails the whole concept. You use historical data to build a model of what shady behavior looks like, and then you use data mining to spot similar patterns happening right now. It's basically pattern recognition on an unbelievable scale.
But all of this, of course, leads to a massive and incredibly important question. With this kind of power, this ability to find patterns in our behavior, our finances, even our phone calls, like the reports about the NSA mining call data to find terror networks, what happens to our privacy?
And that right there, that's the ultimate takeaway. You see, for decades, the biggest challenge was a technical one. The question was, can we even find the patterns hidden in all this data? Well, today, that challenge is pretty much solved. The really hard question we're all facing now is an ethical one. It's no longer about if we can find the gold, it's about how we should use it.